The fascination that humans have always had with the exploration of space has always motivated us to test the limits of what is physically possible. Even while we have made enormous leaps forward in terms of comprehending and studying our own solar system, the possibility of traveling to other star systems is still only a distant fantasy. On the other hand, new discoveries in science and theoretical developments have taken us closer to solving the riddles of interstellar travel in recent years. In this video, we will investigate the present understanding of how interstellar space travel operates, as well as the fascinating potential that it has for the future of humanity. Recognizing the obstacles, the great distances involved in interstellar travel present a number of formidable obstacles that must be overcome. Our present methods of propulsion, such as chemical rockets, are tragically inadequate for the task of traversing the vast distances that separate the stars. Even Alpha Centauri, the star system that is geographically nearest to our own, is around 4.37 light-years away, which is equivalent to over 25 trillion miles. In order to close such vast gaps, we need to come up with creative ideas that are able to overcome the constraints of conventional techniques of propulsion. The potential of advanced propulsion systems. The creation of advanced propulsion systems is one of the potential paths that could lead to interstellar travel in the future. When it comes to propelling spacecraft at tremendous speeds, these technologies rely on the laws and principles of physics. Ion propulsion, which includes the expulsion of charged particles at high velocities in order to generate thrust, is a concept that is gaining popularity and is one that could be used in the future. In spite of the fact that this approach offers a moderate acceleration, it is nonetheless capable of gradually building up to extraordinary speeds over extended distances. In nuclear propulsion, a spaceship is powered by the energy that is emitted as a byproduct of nuclear reactions. This is another intriguing and potentially useful idea. These systems are able to produce enormous thrust because they make use of a controlled nuclear reaction, which helps to cut travel time by a large amount. Wormholes and warp drives. When it comes to the area of science fiction, people frequently consider warp drives and wormholes as the method to attain faster-than-light travel. Recent study has dug into the theoretical foundations that support these conceptions. Nonetheless, these ideas are still considered to be speculative. The research of physicist Miguel Alcubierre provided the impetus for the concept of a warp drive, which proposes the manipulation of spacetime itself to produce a bubble in which space in front of the spacecraft closes while space in its wake expands. This hypothetical warp bubble has the potential to permit travel at speeds greater than the speed of light by effectively avoiding the constraints of the universal speed limit. On the other hand, wormholes are conceptual cut-throughs through spacetime that function analogously to tunnels connecting various locations. These theoretical structures have the potential to make instantaneous travel between massive cosmic distances possible, but the development of these ideas into practical applications is still in its infancy and is contingent on the existence of unusual types of matter and energy. Time dilation and cryogenic stasis are two fascinating aspects of interplanetary travel. One other fascinating component of interplanetary travel is the effect that time dilation has. According to the theory of relativity developed by Albert Einstein, time moves more slowly for things traveling at great speeds in comparison to those that are stationary. Time dilation becomes an increasingly important phenomenon for a spacecraft as it gets closer and closer to the speed of light. Because of this effect, it is possible that time seems to pass far more quickly for travelers than it does for spectators on Earth, even though the latter may see decades or even centuries pass. Cryogenic stasis is a concept that has been presented as a solution to overcome the restrictions of long-term spaceflight. Astronauts would be able to make it through the lengthy travels if they were put into a state of suspended animation. This would cause their metabolic processes to slow down, allowing them to remain alive until they reach their destination. The prospects for interplanetary travel, despite the huge difficulties involved, even though the difficulties involved in interplanetary travel are enormous, scientific and technological developments continue to bring us closer to the realization of this dream. Numerous ongoing programs, such as Breakthrough Starshot, have the overarching goal of developing groundbreaking new methods of propulsion that will enable humans to travel to nearby star systems during their own lifetimes. Additionally, the continuing research into and comprehension of fundamental physics may lead to advancements in the manipulation of spacetime, which may eventually allow for travel at speeds faster than light or the creation of wormholes that can be traveled through. The ability to travel between the stars is considered to be the peak of human aspiration in scientific research. Even though there are still a lot of challenges to overcome, we are getting closer to solving the riddles of interstellar travel thanks to the developments that have been achieved in propulsion systems, theoretical physics, and our knowledge of how time slows down. As we continue to explore the cosmos, it is possible that we will one day see mankind spread across the stars, broadening our horizons and discovering the great wonders of the universe.